Okay, so I'm going to go through electric forces and fields and just kind of walk you through some of these notes as a review. So, Benjamin Franklin is one of the pioneers of electricity research, and in 1752, there's this idea that he flew a kite with a key on it, and it shocked him and all this stuff. Well, people who've tried to recreate that experiment killed themselves. So, we think Ben Franklin did something like that, but maybe perhaps a little bit different. But regardless of what the particulars of that experiment, he's the person that came up with the two types of charge, and he called them positive and negative. And it's important to realize that those are not mathematic ideas. That's just one or the other. Doesn't mean that one is actually negative and one is actually positive mathematically. Another concept is that like charges repel and unlike charges attract. That's like the fundamental rule of electricity. And then charges are conserved and charge is also quantized. It comes in these little bits. Okay, we'll talk more about that later. All right, the two kinds of electric charge, positive, negative. Why positive, negative? Like I said before, doesn't really matter. It's arbitrary. So one example you have for this is you can take two balloons, rub them together, and they attract. And the deal is that in order to have those two balloons attract, you're basically scraping electrons off of one and putting it on the other. So you're making one positive and one negative. Now, if you rub both balloons on your hair, you're stripping electrons from your hair onto both balloons. So now both balloons are negative and your hair is positive. Thus, all balloons rubbed on your head all attract back to your head. But you'll find that they repel each other because they've been made both negative. Okay, the fundamental rule of electricity. Like charges repel, unlike charges attract, or opposites attract. Once again, this comes back to positive and negative. And just anything that's negative attracts a positive and repels a negative. Very simple. And there's various experiments where you can do this sort of thing, where you show that negatives repel, positives repel, and that sort of thing. Okay, the next idea, electric charge is conserved. Realize that when you talk about charge, all you're doing is moving electrons around. Why electrons? Well, electrons are much, much easier to move than protons. You might remember from chemistry that protons are kind of stuck inside an atom, while electrons kind of are on the outside and they're free to move. So the easier it is to move the electrons around, the more electricity you're going to move. And that's why charge is conserved. You're not creating anything, you're just moving electrons around. Okay, electric charge is quantized. And quantized means that it comes in these little amounts. And the deal is that there's this thing that is the elemental charge. And every electron and every proton has this one charge. And it's 1.6 e to negative 19 coulombs. Okay, coulomb is the unit for charge. So any electron or any proton comes with this elemental charge. And there's no way to have half of one or a third of one. You can only go up or down by this much, 1.6 e to the negative 19. That's why electrical charge is quantized. And this was discovered by Robert Millikan in an oil drop experiment. Okay, there's several ways that we basically categorize objects. And we do it by how much they transfer electric charge. Now, electric conductors, you have electrical charges that move really freely. And that would be silver, gold, copper, and aluminum. And they're all metals basically, and they all have this idea of a sea of electrons where chemically they all share their electrons. And so it's very easy to make them move around. And so they're very good conductors. Insulators, the electrons are kind of stuck in those. And you have some examples below where you have glass, rubber, silk, plastic, and pure water. Now, water with electrolytes and minerals in it actually become pretty good conductors. And the fact of the matter is, your body moves electrical impulses around and they do so with basically a salt water. So pure water can be a great insulator. Add a little mineral to it, and it's a pretty good conductor. All right, semiconductors are kind of an oddball. Sometimes it's an insulator, sometimes it's a conductor. And they're pretty predictable in when they switch from one to the other. So they make actually a nice little switch. And silicone is like what they make computer chips out of, as you can see right over here. This is your computer chip. And they almost act like a little switch. They make really nice computer chips. Superconductors, they are this really neat material that's probably the future of material sciences, and they have no resistance. And what that means is that basically you can move electricity around with no loss. The way they move electricity around now with copper and things like that, there's a lot of loss of electricity to resistance. We're talking about like half and things like that. So moving electricity around is very, very expensive when you use copper. Superconductors would be great because you lose no electricity to resistance. Only problem is that the only thing that really we have now that are superconductors are supercooled ceramics, things that are almost 0 degrees Kelvin. So not very practical, but if we could get them closer to room temperature, then they could be pretty amazing substances. All right, let's look at some examples of charge. Here we have two charged spheres that are obviously repelling each other. What can you know about their charges? All right, now think about this for a second. They both repel each other. Obviously, they're not opposites, okay? But you don't know if they're positive or negative. They could both be negative, or they could both be positive, right? Because either way, they would repel each other. So we're going to go with 4. Both are positive or both are negative. All right, so look at this example. You have this metal ball hanging from the ceiling by a thread, and it's attracted to this positive rod sitting beside it. Obviously, they're moving toward each other. So what charge is this ball? Okay, now opposites attract, so it could be very reasonable that this is a negative. But there's more to the story there, because this could also be neutral. And the reason is because a neutral object will polarize. And so the negatives will go to this side, and that'll leave a net positive on that side. So it could be negative or it could be neutral and just polarized. Now, we call that polarization because you have one area that's more negative, one area that's more positive, which means it's kind of separated into poles, kind of like the North Pole and the South Pole. Okay, now this is something to show you induction. How do you charge something without actually touching it? All right, now you have this 0 charge and 0 charge when you start out. So right here, you're starting with 0 on both of them, I mean they're both neutral, okay? And you bring this positive next to the blue one. And what happens is the negatives rush over to be on this side, and that leaves this side way more positive. Okay, so you have this polarization happening, okay, because you connected the two and you allowed negatives to rush over. So our negatives kind of rushed over this way and left this side more positive. Now, when you take the wire away, when you take that wire off like you do right here, then you basically leave this as negative and you isolate the charge. So now that's negative and that's positive. Okay? and you pull the positive bar away, and at the end you're left with, well, it's got to just stay the same way. There's nowhere for the negatives to go now. So this is really negative, and this is really positive when you leave it. And that's what you're left with, and that is called charging by induction. So just to go over some of the terms we've mentioned, polarization is just charge separation within an object. So you have a neutral object, but you have regions that are positive and negative inside of it. So even though overall something can be neutral, it can have charge in it because of polarization. And if you bring an object close to something, so say you bring a negative rod close to like a wall, you're going to polarize that wall because the positives are going to stay close to that negative rod and the negatives are going to rush away. So you actually can attract things that are neutral just because they naturally become polarized. Now when you rub things, typically you're going to move some electrons, and so you're going to charge by friction. Okay, you're going to take some electrons off, put them somewhere else, and you're going to make a charge on something just by scraping off electrons. And so if you rub like a ruler even with something like fur or something, you can pick things up and make electrical forces. Now another term we talk about is grounding. And the earth is actually a pretty good conductor, and the earth has ridiculous amounts of positive and negative. So almost anything that's charged will be able to be neutralized by the ground because the ground's so big and has so many different charges in it. So basically all things that come in contact with the ground become neutralized. And the ground is able to give any electrons or take any electrons away that you might want to be giving. So think about it as like this giant charge bank where you can give or take from it as much as you want. Okay, so this is just another example of charging by induction. So if you want to do that, there's a process. So you could ground a rod first, and then bring a charged rod next to it. So here we grounded it. Then we bring this charged rod next to it, and this makes polarization. You have a positive side and a more negative side, but the negatives are going to tend to just go down into the ground. And so you leave a really positive rod when you break the ground and then pull the rod away. And you're left with just a really positive rod. And there's your process. You just charged it by induction. Okay, so that's just a brief overview of the beginning concepts of electricity. So review this and understand it because this is the basics of pretty much everything we talk about from here on out.